All right, hey everyone, thanks for joining. My name is Bruce Lin, and I support developer product marketing here at Facebook. And our main focus on the team is to make sure that you, the developers, have access to the tools, the educational resources, and the communities that you need to build the latest technologies. And so one area that's come up a lot has been machine learning and machine learning development. So as a result, I think at F8 this year, we've got 13 sessions covering AI, everything from how Facebook builds and deploys machine learning systems to new open source tools that you can go check out today. So for anyone that's new to machine learning development, I wanted to spend the next 15 minutes really quickly going through some of the common terminology and the common concepts you'll come across, and also take a look at the developer workflow and some developer tools that you can start using now. So the hope is to provide you some quick context for understanding the sessions happening later today and tomorrow so you can better understand how they can be relevant to your work. So let's start with some terminology. So AI, or artificial intelligence, refers to the ability for a machine to complete tasks that involve human-level intelligence as well as or better than a human can. So when you think about popular culture and how they reference AI, that's usually referencing AGI, or artificial general intelligence. So this refers to a machine that can perform any intellectual task as well as a human can. So you think of your favorite droid from a galaxy far away, this is usually AGI. In contrast to that, most of what we'll talk about in this session, as well as today and tomorrow, and a lot of the work that's being done now, is still a narrow AI, which is the ability for a machine to perform a specific task. So that could be understanding what's in an image, or it could be translating languages, or it could be making business predictions for your company. So machine learning and artificial intelligence are two terms that are used pretty interchangeably. I know I've been using them interchangeably for the last minute or so. But it's actually not the same thing. So machine learning is a subfield of AI that involves giving a machine the ability to perform a task without being explicitly programmed to do so. So you can imagine in situations it can be really tedious or difficult or sometimes even impossible to try and code every single rule that a machine would need in order to successfully perform a task. We can use machine learning instead. And there's also other subfields of AI, but we'll focus on machine learning. All right, so deep learning. So deep learning is a type of machine learning that uses artificial neural networks that can learn the associations between inputs and outputs. And deep learning has actually gotten really popular and driven a lot of the advances in AI in the past few years. And this is largely due to researchers and engineers applying existing and new techniques to larger and larger data sets, which allows to train models more accurately. And also the use of more higher performance hardware. So especially the use of GPUs to perform all the computations that we need for machine learning. So mention that deep learning uses artificial neural networks. So artificial neural networks are computing systems made up of interconnected nodes. And when we talk about deep learning, we're referring to computing systems that use many layers of these interconnected nodes. So the node is the basic unit of a neural network where computations are performed. Taking a deeper look at that, we can understand nodes as a linear transformation enclosed in a nonlinear transformation. So in the linear transformation, the input data comes in, and you multiply it by a number or a weight, and then the addition of a bias or a constant. So you see the term weights and biases, this is what it's referring to. So after the linear transformation, we apply a nonlinear transformation or an activation function. And this is what allows us to go from inputs and outputs that don't always have a linear relationship. And in a deep neural network, the outputs of this linear and nonlinear transformation then become the inputs to the next layer of these nodes. So mathematically, we can write that out as y, or the output, equals the function of the weighted sum of the inputs and the addition of a bias. So the main idea here is that through these simple or relatively simple mathematical computations, and a lot of these computations, deep learning allows us to model the relationship, and oftentimes complex relationships, between inputs and outputs that otherwise would be very far apart. So that could be between an image and a sentence describing what's happening in that image. So before we move on from some of the common terminology, I want to quickly touch on the learning process. So how does a machine learn? This happens through the model training process. So in model training, the first step is the forward pass. So at this point, the neural network is activated, and data flows through the neural network in the forward direction, and we compute the output. So at this point in time, the weights and biases are still kind of randomly assigned. We don't actually know the right parameters that are going to result in the correct output to be computed. We then compare the computed output with the ground truth, or our desired output, and we look at the total error. And then that error is propagated backwards through the neural network to adjust the parameters to more accurately calculate the correct output. And so that's done through this concept of backpropagation. And lastly, gradient descent is a commonly used optimization algorithm that helps us in adjusting parameters to minimize that total error between the computed output and the desired output. It allows us to understand how the error changes in a response to a change in the parameter. So that's a super basic and quick explanation of supervised learning, but there's also other learning techniques such as unsupervised learning and reinforcement learning. All right, so switching gears a bit, I want to talk about how we apply AI at Facebook, since it's not always something that's super obvious as you're interacting with the products and experiences on Facebook. So you've probably used recommendations before, so this is one experience that you're probably familiar with that uses machine learning to power that experience. We also have an immersive new video calling device that we launched last year called Portal. And Portal has this really cool feature called Smart Camera. And Smart Camera keeps the camera, as it sounds, focused on what's happening. So whether you're talking or someone else is talking, or you just want to make sure that your whole family fits in the frame and you're not sort of cutting people out, that's where Smart Camera comes in, and that's powered by machine learning. So these are examples of how you can use machine learning to build experiences that bring people that much closer together, even if they can't physically be near each other. And lastly, for completely new experiences like augmented reality or virtual reality, we also use machine learning to power some of those experiences there. So an example here is Oculus Lip Sync. So with Oculus Lip Sync, your avatar in a virtual environment can sync the lip movements to what you're saying in real time to make it that much more natural when you're interacting. All right, so let's talk about some of the developer tools that you can use and the developer workflow involved to build some of these experiences. So thanks to the proliferation of a lot of different developer tools and a lot more accessible developer tools, it's now easier for developers with varying levels of experience or familiarity to get started with machine learning. So we're going to bucket the steps into kind of 4 rough steps. The first one would be determining your approach. So this is a point in time where you should really spend the right amount of time figuring out how machine learning is going to solve the problem that you have, and how you're going to get that data, what you're going to do with it, and ultimately what you're going to do with the output of that machine learning model to solve whatever you're looking to do. So once you've figured out your plan of attack, you'll need to prepare that data. This is another step that could also take a bit of time depending on what state your data is in. But at this point, you want to prepare, annotate, pre-process, and generally get your data ready to be used by your machine learning model. And then you get to move into the fun part of building and training your model, which we talked about a little bit earlier. And once you've evaluated your model and you feel like you have a good proven model that's ready to go, you'll transition it to a production environment where you can deploy that model and use it in your end application. And then you also need to scale that up depending on your needs. So obviously, these steps require some sort of hardware and software stack. So we're going to look at this, again, at a high level. We can roughly bucket it. On the left side, you have your data science library. So these are the steps or the tools that you're going to use to clean and pre-process and annotate your data. Again, get it ready for your machine learning model. And then in the middle column, you have your various components for building, training, and evaluating your neural network. So at the bottom, you have hardware. So this is your actual CPUs and GPUs that you're going to use to perform those calculations in your model. And then a little bit above that, you have your frameworks. So if you've heard of frameworks like PyTorch, PyTorch and other frameworks reduce a lot of the cognitive overhead involved in building and training your models so that you can focus more on the problem that you're trying to solve. And you'll hear more about PyTorch tomorrow in a couple different talks. And then above the frameworks, there are many libraries that can help support and accelerate your development. So this could be in computer vision, for example, where you can use the computer vision library, which gives you a lot of the components needed so that you can more quickly get started. And then on the right side, you have your deployment platform. So we mentioned once you have that model ready to go, you'll need to transition to some sort of production environment so you can serve that model and use it in your end application. So I know this looks like a lot potentially, but luckily there's actually a lot of different open source tools that you can cobble together and create your own stack But there's also many managed platforms and services and APIs out there that you can use so that you can get started more easily. So if we were to look at it in terms of level of abstraction for how you might interact with these different tools, starting from low to high, at the lower level of abstraction, we have frameworks. I mentioned PyTorch earlier. And so this gives you kind of both ease of use as well as the fine level of granularity and the ability to customize and work with a lot of different concepts and techniques and architectures so that you can kind of go and explore. So this is where a lot of our researchers at Facebook will use this type of tool. On the other side of things, though, if you're really just looking to incorporate kind of proven standard machine learning capabilities into your end application, there are domain APIs that you can use that are more or less plug and play. Right? So you can, if it's a vision API, send in images and outcomes, the classification, along with confidence levels. And kind of in between these two levels of abstraction, you have managed platforms as well as fine-tunable APIs. So fine-tunable APIs, much like the domain APIs we just talked about, basically allow you to get that kind of plug-and-play sort of ease of use, but allow you to customize it on specific images for if it's a vision API, for example. So if you're doing certain medical imaging, you might want to fine-tune that model to be more accurate for your type of needs. And then the managed platforms, you can think of this as sort of a fabric that goes across a number of different components so that these assemble all the various tools that you might need. It makes it a little bit easier for you to work across them. So these are just some of the ways that you can get started. I encourage you to kind of explore and check out what makes sense for you based on what your machine learning needs are. There's also a couple other tools or resources that I wanted to point out really quickly before we wrap up. So as you know, Facebook does a lot of our AI work in the open. So our researchers regularly publish papers that you can go check out. They'll publish associated code so you can go explore there. And we also open source a lot of various tools that you'll also hear about today and tomorrow that you can use to get started in machine learning and also with data science. And so if you check out facebook.ai, there's a number of open source tools there that you can go and use immediately. If you're interested in starting to play with frameworks and exploring what that looks like, I encourage you to check out pytorch.org for the PyTorch framework. There's actually tutorials on there that you can open up right on your browser in an interactive notebook environment and start to see how things work without any setup. And if you're looking for educational resources, so obviously this was a super short talk, so as you want to kind of dig in more, we work with a lot of companies like Udacity to provide both free courses that you can go check out just to kind of get a taste for what machine learning development is all about. But there's also full-on nano degrees too, and a lot of these are actually taught on PyTorch, so you can kind of continue your education in a way that is using the same sort of tool set. And there's also really great educators in the community as well. So we work with folks like Fast.ai. So Fast.ai has both a software library that makes it easier to work with frameworks like PyTorch, as well as open courses that you can go and check out. So that's it. So hopefully this gives you some context for better understanding some of the other AI sessions that are going to happen at F8. As I mentioned, there's a number of them, both today and tomorrow. So I encourage you to check them out and see how they can be relevant to your work. All right, thanks again, everyone, and have a great F8.